Lecture 3.1, Derivatives. And the photo is the Great Sand Dunes National Monument in Colorado. The limit as h goes to 0 of f of a plus h minus f of a over h is called the derivative of f at a. We write f prime x equals the limit as h goes to 0 of f of x plus h minus f of x over h, which we could read as the derivative of f with respect to x is. There are many ways to write the derivative of y equals f of x. We can write f prime x, or the derivative of f with respect to x. Another notation is y prime. Still another notation is dy dx. Or the derivative of y with respect to x. Or we can write df dx. Which is also read the derivative of f with respect to x. Or we can write d dx of f of x. D dx of f of x. Or the derivative of f of x. All these different forms of the derivative have different applications, but mostly they can be used interchangeably. Note: dx does not mean d times x. dy does not mean d times y. dy dx does not mean dy divided by dx. Except when it is convenient to think of it as division. df does not mean df divided by dx. Except when it is convenient to think of it as division. d dx of f of x does not mean d dx times f of x, except when it is convenient to treat it that way. In the future, all will become clear. Consider this function. The derivative is the slope of the original function. So we could graph the derivative by graphing the slope of the original function. In the interval from 0 to 1, the slope is 2. That is, up 2 over 1. So the derivative is 2. The derivative is defined at the endpoints of a function on a closed interval. From 1 to 4, the slope is 1/3, so the derivative is 1/3. From 4 to 6, the slope is 0, so the derivative is 0. And from 6 to 9, the slope is -1, so the derivative is 1. Notice that when the original function has corners, here, here, and here, the original function does not have a slope defined, so the derivative is not defined. In this function, y equals x squared minus 3, we can find the derivative using the difference quotient, or definition of derivative, by taking the limit as h goes to 0 of x plus h squared minus 3 minus x squared minus 3 all over h. So we expand the binomial square and eliminate the parentheses. That allows us to cancel the x squared and then cancel an h. So now we have y prime equals the limit as h goes to 0 of 2x plus h. And as h goes to 0, what's left is 2x. So now we have a general expression for the derivative, that is, a general expression for the slope of the original function at any point. And if we graph the derivative, we see that the derivative matches the slope. At x equals 0, the slope is 0, and the derivative is 0. If we look at the original function, there's a negative slope on the left-hand side and a negative derivative, a positive slope on the right-hand side, and a positive derivative. A function is differentiable if it has a derivative everywhere in its domain. It must be continuous and smooth. Functions on closed intervals must have one-sided derivatives defined at the endpoints. In this chapter, we will be finding derivatives by hand, but you can also find derivatives on the Ti Nspire. For example, to find the derivative of y equals x squared, you can press Menu, 4, Calculus, 1, Derivative, and the derivative template appears. Enter the variable of differentiation and the function. Then press Enter, and the calculator returns the derivative 2x. You can find this same command and save a keystroke by using a keyboard shortcut. Shift minus. And that's the minus sign, not the negative sign.